For this question, we have, what is a relative mass formula for magnesium nitrate? Okay, so right away, relative mass, think of it as solving for your molecular mass. And technically, yes, this is relative because molecular masses can vary based on the type of isotopes that are actually forming that compound. But in this case, what they're saying in terms of this is that they want you to gather all the different atomic masses of each component of magnesium nitrate and add it together to get a total atomic mass, if that makes sense. But now let's say we weren't given what magnesium nitrate was. We can still use our periodic table to figure out what this molecular formula would be. Magnesium would just translate straight to magnesium, Mg. And because it's on the second column, we know it comes as a 2+ ion. Nitrate, on the other hand, is something you have to memorize, okay? Where it will be nitrogen and a certain amount of oxygens. For nitrate, the ending in ATE, it's NO3-, okay? So when we have a 2+ and a 1-, the only way for the charges to be a net of 0 will be 2 of the nitrates. So our formula, as it shows there, is MgNO32. This is indeed our formula for magnesium nitrate. Now, with that being said, to find the relative mass, we have to add up the constituents. So we have 1 magnesium, we have 2 nitrogen, and we have to do like multiply like that. And so that means if we have 2 nitrogen, we have 6 oxygen, okay? And then we get the molecular or the atomic masses for each. Magnesium from the periodic table is 24.305. Nitrogen is 14.007. And oxygen is 15.999. So when you multiply these, we still get 24.305, okay? And then we get also for this 2 times 14 is 28.014. And then when we do this one, it will be 63 point, whoops, not 63. It will be 95.994. And then we'd add all of these together because you have to add up the constituents. So it'd be plus 28.014 plus 24.305, okay? And in total we get 148.313 grams per mole for the relative mass for magnesium nitrate, okay? And let's see how we did. So exactly, they have the atomic masses of each, which is here. 24.3 is what they use for magnesium, and then for nitrogen they use 14, and for oxygen they use 16, and together they got 148.3 atomic mass units. I prefer to keep it in grams per mole, just because that's usually what they're asking for the molecular mass. But for this question, just to keep it similar, 148.313 atomic mass units also works in this case as well, because either way we know that it's the relative mass because we don't know exactly which isotopes are being used. So that's why we usually generalize with the relative mass, aka the molar mass. And now question number 6.